In the bottle, I've got some copper-2 sulfate solution, which was made from just dissolving some copper-2 sulfate crystals in water. So it's about 0.1 moles per decimetre cubed concentration, although the concentration doesn't really matter. Hopefully you can see here that this is a nice blue solution. Now, in actual fact, when copper sulfate dissolves in water, CuSO4AQ, the Cu2 plus ions do not exist independently and move freely. What happens instead, because this is an example of a transition metal ion, is it forms something which looks like this. So I'll just draw a shape around here, and hopefully you can see that this is an octahedral shape. And attached to each end of those bonds is a water molecule. Now notice how I've drawn that water molecule with the oxygen attached to the bond and the two hydrogens separately, like so. H2O all the way around there. Now these bonds here are formed when the lone pair of electrons on the oxygen atom donates both of those electrons and forms this bond here. This bond here, therefore, is a dative covalent bond. So each of these bonds are dative covalent bonds, and the copper-2 ion in the centre is attached to 6 of those in this case. This complex has an overall charge of 2+. Now, because the water molecules, or ligands as we call them, the water ligands within this complex are uncharged, the overall charge on the complex is 2+, because this was copper-2 sulfate here. The number of dative covalent bonds forming to that metal ion is 6. So we say that the coordination number is 6. Notice that the number of ligands here is 6, but that doesn't relate to the coordination number. The coordination number is the number of dative covalent bonds formed to that central metal ion. And it's the same in this case as the number of ligands, because each ligand in this example forms one covalent bond. So we will call those ligands unidentate or monodentate ligands, like so. So the shape around this particular complex ion is octahedral. So bits of terminology then relating to transition metals. There's lots of the key properties of transition metal ions here that you can see all in this one very straightforward test tube copper sulfate solution. Firstly, lots of transition metal ions are colourful. And this one particularly is blue. We will meet different coloured examples which you need to learn, but we'll also meet the origin of the colours of those later in the course. Transition metal ions form complex ions, and the complex ion is the central transition metal ion which is surrounded by ligands, and each ligand donates one or more lone pairs of electrons to that central metal ion to form dative covalent bonds. In this example, the water is a small and uncharged ligand, a unidentate ligand, so each of the ligands forms one bond with that central metal ion, and you can fit 6 around there, so it forms this octahedral shape. And the overall charge on this complex ion is 2+. It would be a little bit tedious to have to draw this out in this format every time you wanted to represent this on the page, and so another representation of this ion is Cu H2O 6 times with big square brackets around it and a 2+ charge Aq. Notice that the sulfate ion would also be in solution, but that's dissociated from the copper-2+ ions when that solution forms. So we're primarily focusing, or completely focusing in actual fact, on the transition metal ion